graphical representation of linear equation in two variables. Let us consider an example. We have a linear equation x plus 10y minus 115 equal to 0. To solve graphically, we first need to make a table, different values of x and y. The ordered pairs x and y will give you a set of points which will be plotted on the graph to give you the straight line. So, the first step is to make y the subject of the formula. Rearranging the equation, I have y is equal to 115 minus x upon 10. Now, next, forming a table, substituting different values of x will get different values of y. Now, for plotting a straight line, only 2 points are required. It follows from Euclid's geometry that through one point, had we got only 1 point, then it would not have been possible to construct a line, because through 1 point infinitely many straight lines would pass, but for constructing a line minimum 2 points are required. If I have 2 points, I have one unique line passing through it. So, we will find out two values of y for corresponding values of x. Smartly we will choose those values of x which will be exactly divisible by 10. So, if I make 115 minus x exactly divisible by 10, I have to subtract multiples of 5 from it. So, if I take one negative value, suppose minus 15, I will get 12 as the answer, and if I take plus 15, I will take 10 as the answer. So, it is your choice, whatever, we can choose any two values of x and we will get corresponding values of y. Now, from here, x plus 15y minus 165 equal to 0, another set of equation, and forming a table, again I will see that if I make a table, I will see that minus 5 and minus 15 and 12 and 15 and 10. These are the two pairs which we are getting, and 15 and 10 is common to both the equations. The ordered pair 15 and 10 is common to both the equations. So, x is equal to 15 and y is equal to 10. This is the point which is a common point, or a common point through which both the lines are passing, because in both the tables I am getting this combination or ordered pair. This is the point where the two lines intersect. So, fixed component, which was the representative of my y, of my x represented fixed component is equal to 15 and variable component is 10. So, the value of the x is 15 and value of y is 10. Now, if I represent the same situation graphically, I can see two straight lines and both of them intersect at the point 15, 10. Now, that situation which we discussed, we dealt with two linear equations, and when they were represented graphically, they intersected at a point. But it is not necessary that every time two lines will intersect at a point. There may be different conditions, and what are the possible conditions? The possible conditions are the two lines may be parallel, not meeting each other at all. They may intersect at a point which we just saw, and there is only one point at which they will intersect. If they are exactly coinciding with each other, they will be meeting at several points. They will be overlapping each other. So, there is a difference between intersecting lines and coincident lines. In intersecting lines, the lines will intersect at one unique point, whereas in coincident lines, they will fall over each other. There will be many such points, infinitely many points.